All right, so the second part of this section is going to focus on both minimums and maximums, so our turning points, and then how the turning points divide our polynomial, our graph, into sections that are increasing and sections that are decreasing. To first define that idea, a function is considered to be increasing when the y values are increasing from left to right. So they're rising from left to right, or if we were looking at just that section, it would look like it has a positive slope in just that section. On the contrary, it is considered decreasing when the y values are decreasing from left to right, or the graph falls, appears to have a negative slope in just that particular section. So when we are asked to describe the sections that are increasing or decreasing, we're asking about the x values or the domain in which it is increasing or decreasing. The numbers that we list are going to represent the domain because the values of the range, the y values, are increasing. Gets a little confusing there in the language, but let's take a look at that here in practice. If I were to ask you to first shade the graph where it is increasing, what would that look like? Well, these are the two sections that I've highlighted that the graph is increasing. It is moving from left to right. The graph is moving up. The y values are getting bigger as the x values are getting bigger. And when it asks to give the intervals, it's listing the domain. We're going to do this in interval notation. I want us to look at this as -1, -2, -3, -4. This is -5. And it continues to increase until it gets to here, which this x value is -3. So on that interval, now, careful, because I said -5, but what's happening? It's actually going to be increasing because the arrow goes forever. And so it's actually increasing all the way over here forever and ever. That's actually -infinity. So it starts increasing as far to the left as this graph goes, which is -infinity. And it continues to increase until we get to 3, or -3, I should say. In interval notation, we have to decide whether I'm going to end that with a parentheses or a brace or bracket like that. And I'm going to tell you that when we're talking about increasing or decreasing, it's always going to be with a bracket or a parentheses. And the reason, and it will get more complicated, it'll be easier to describe when we're in person, but is at actually -3, it is no longer increasing. It is no longer decreasing. It's not really doing anything. It's just kind of there. So we're always going to say it's not increasing there. It's not decreasing there. And that's represented with the parentheses. Then the graph starts decreasing, but then it starts increasing again here at an x value of -1, and it increases all the way until the x value becomes a +2. So we increase as well from -1 until +2, again parentheses. In between these, we should always list a union. But we're not done. I missed one. It's increasing here as well. And it increases again forever. It starts increasing at +4, so I'm going to make a union symbol. Starts at +4 until forever. That forever is +infinity. Take that and see if you can now create the list of the values of x where the function is decreasing. Okay, and so for those values, it should be from -3 to -1, and from 2 to 4, and we use the union symbol in between. So summary, increasing as it's going up. We start turning and we go down, we're decreasing. It turns, another turning point, and we go up. That's increasing. Hits the turning point, we go down. That's decreasing. Hits a turning point, goes up. Start increasing and never stops increasing, and that's why we ended and began with our infinities. Okay, on the next problem, we're kind of putting a lot of this together. I want us to describe our end behavior, state the number of turning points and the coordinates of them, and then describe when the function is increasing and when the function is decreasing. Go ahead and try, at the bare minimum right now, try those two parts. All right, so I'm identified them on the graph. My end behavior is going up on both sides. So as x goes to negative infinity, y goes to infinity. As x goes to infinity, y also is going to infinity. I have 3 turning points, and these are the coordinates. Careful with these. I know those look like negatives. It's just because that line, those numbers got placed in the weird spot. So you just got to be careful with that. Okay. Now with that information, take a shot at writing the intervals where the function is increasing. Again, focusing on the x coordinates, it is increasing from -2 to 0, and then again from 2 to infinity. Or it is decreasing from -infinity until we hit -2, and then again at 0 until we hit +2. All right, so I'm going to ask you to do this part here a little piecemeal. We're going to do the end behavior, and we're going to plot these ordered pairs, and then just sketch the end behavior. This is going to be something that you got to pay attention to. I just want to sketch the end behavior, and we'll talk about that here in a moment. So take a moment, describe the end behavior, the number of turning points, and plot these ordered pairs, and then pause, don't do anything else. And before I plot my points, I'm going to tell you that I just screwed you up because I had a typo here. That should have been 0, -2. So if you plotted 0, 2, just go ahead and ignore that one and plot 0, -2. My mistake there. So if you had a pencil, you were able to draw these points. And what we know now is that we have an end behavior that is going up as we go to the left and down as we go to the right. There's possibly 2 turning points, but we don't know much more. Here's what I can do. I know that as x goes to -infinity, my y is going to +infinity. So I know on the far left of my graph here, I'll call this point my far left. It's moving up. That's just sketching my end behavior. That's sketching this end behavior here. And then I also know on the far right, as x goes to +infinity, my y is going to -infinity. So I'm going down on the right. So I can go to this point and sketch that. It's going down on the right. Now I don't know what's happening in the middle. I know I'm hitting this point. I know I'm hitting this point. But I don't know. And I know I'm only turning at most 2 times. So I could go down through there and up. I can't go like down, up. So there's going to have to be something down and up and then back down. All right, so we're going to have to figure that out. And that's where finding the exact location of your maximums and your minimums, of your turning points, is so important. And that's where we can bring our graphing calculators back into play. I can use my calculator to find these points. So in my calculator, I go to my y equals, I clear everything out, I type in my -x to the 3rd power plus 2x squared minus x minus 2 with the magic of video. And I'm going to hit graph, but really I'm just going to hit zoom standard because I want to go to my standard viewing window. I now see it actually does turn twice. Once here, then it starts increasing a little bit, and then another time here and it starts decreasing. So I have to find those exact locations. Second, trace. The first one is a minimum. I press 3. This point here is going to be a minimum. I need to give it a left bound. So I'm to the left of it and I hit enter. A right bound. I go to the right of it, but not too far right. I just want to make sure I'm to the right. Now I just saw my cursor moving up, so I know I've gone up a little bit. I hit enter. It says guess. I hit enter a 3rd time. There's my minimum. So I'm going to start by writing that down, then find my maximum. Maximum is just going to be to the right here a little bit, so I need to do my second trace. This one is a maximum. Left bound, I'm to the left of it. I hit enter. I go give it a right bound. I'm watching my cursor, and now I saw it start to move down. Now I know I'm far enough to the right. I might do one more point. Hit enter. It says guess. I hit enter a 3rd time, and here's my maximum. Now I'm going to round that to a +1. If it's that 0.99999, I can do that. And I can sketch this now. I can add that to my sketch. I have a minimum at 0.33 and negative 2.148. So it's somewhere in between 0 and 1 and a little bit past there. So it's barely in there, but it's in there. And my maximum is 1, negative 2. Well, I already have that point plotted. So if I zoom in there to try to sketch the rest of this, go to a smaller purple pen, I know that I'm connecting these. I am curving down, up, and down, and I have a much more accurate sketch of what's happening. That information is now what I can use to determine the intervals where the graph is increasing. Now, I had a max of 2 turning points, and I actually had 2. You don't always know that that's going to be the case. They won't always match. So when I talk about my graph being in the intervals of increasing, it's tiny. It's just right there that it's increasing in between my 2 turning points. Those 2 turning points are these values here, this x value and this x value. My function is increasing from 0.33 until 1, and that's it. It's decreasing here to the left and here to the right from negative infinity until I get to 0.33, the union, again, with everything from 1 until positive infinity. Okay, there's going to be one more video with the last problem on these notes.